Hi, this is Dr. John Bergduff. In this video, I want to show you how base 10 blocks, a wonderful type of manipulative, can be used to illustrate subtraction of whole numbers. Now, subtraction, the physical action that I want to focus on that represents subtraction is taking away. So when I look at 53 minus 27, I'm thinking of taking the number 53 and somehow taking away from it 27. Over here on the right, I have illustrated the number 53, 5 longs and 3 units. I'm not going to need to illustrate the number 27 like I did with addition, because in subtraction, I'm taking the one single number and taking away from it. But this will illustrate the standard algorithm for subtraction incredibly well, as long as we think in terms of taking away. While I play with the manipulatives over here, I also want to create a chart to keep track of what's going on. So I'm going to represent the number that I have here in terms of longs and units. I have 5 longs and 3 units. And in my chart over here, I want to keep track of the taking away that I want to do. So that's my subtraction. I'm going to take away, and eventually this is showing me that what I want to take away is 2 longs and 7 units. We don't do that all at once. We start in the units place and try to take away from there, and we immediately hit a snag. This says that we want to start with 3 units and take away 7 units. But the problem is I don't have enough units to take that many away. So we're going to do an exchange. Because one of these longs is really 10 units put together, I can take a long and trade it out for 10 units. I have here what I believe is 10 units. Slide that over a little bit. Again, it's incredibly important to let your students, if you're a teacher, observe that this really is 10 units. See that that's the same thing, that the 10 units are the same as the one long. So they really can exchange or trade that long, which is going to get out of the picture, for 10 units that you can put over here with the other units. Let's even write down in our chart what we've done so far. I took away a long, and in the process created 10 more units, which means I now have 13 units. I'm going to write it like that. 13 units is perfect because I can take away 7 units from that. Here's my 13. I'm going to just take away 1, 2, 3, 4, 5, 6, 7. Those are taken away. Get them out of the field of vision, and we can look and see what we have left. 1, 2, 3, 4, 5, 6, 6 units left. And that's exactly right. 13 minus 7 is 6. Now, in the meantime, I have 1 fewer long that I began with, but that's okay. I now will take the 4 longs that I have left and take away 2 of them. So again, I take away 2. That leaves me with 2 longs and 6 units. And we illustrate that right here perfectly as the number 26. The important thing to observe is that what we have done here kinesthetically by playing with the blocks and exchanging and taking away is we've really recreated the standard algorithm for subtraction of whole numbers. Let's look at that as we ordinarily would do and see that what we really have done is we've taken this chart, we're going to take this chart and take off all the lines and labels basically, but do the same things. My ones place is my units place. And this is telling me to take away 7 ones from 3, and that's not enough. So what we do is in more traditional language, we borrow from the tens place. Exchange is kind of a better word to go along with the manipulatives, but borrow is the traditional word. That creates 10 extra units to put with the 3 we already had. Now there's 13 units. And I can take away 7, and it gives me 6. And then in the longs place, 4 minus 2, 4 take away 2 is 26. That's the standard algorithm. It's just the base 10 blocks in an abstract form. So this can really help your students understand what's happening in that abstract algorithm. Let's do one that's a little bit, has bigger numbers. I'm not going to say it's harder, it just has bigger numbers, and do the same sort of thing. So again, when you're doing subtraction, you don't create both numbers. You create the first number and you take away from it. This is 1,000. The thousands place is represented by a block. So I have a block. The hundreds place is represented by flats. This is saying I don't have any flats. But I do have 2 longs and 3 units. I'm going to leave a little, since I've got the space, I'm going to leave a little area here where the flats ordinarily would have been, just so I'm kind of aware that that is gone. And I've got my 3 longs, my 3 units, sorry, my 2 longs, no flats, and a block, a cube. Creating a table to explain what's going on here. Cube, flats, sorry, I got to slide that over a little bit. Longs, units. I am starting with 1 cube, no flats, 2 longs, and 3 units. And eventually I want to take away from that 8 flats, 6 longs, 5 units. Again, we're not going to try to recreate the number 865. That just illustrates what we are taking away. And you'll see many of the same challenges. The first column is telling me that I want to start with my 3 units and take away 5 units. But I don't have 5 units. So what I will do, much like before, is I'll take one of my longs, trade it out for 10 units. Just create a little space here just temporarily. Let's put a whole bunch of units out here. See if that's 10 or not. I can count them, but better for your students, I line them up. And yes, indeed, I counted correctly. I have 10 units to replace the 1 long. So the long goes away and this joins me among my units. Now what I have left is only 1 long, because I started with 2 and I took 1 away. This creates for me 13 units. So I put a 1 right there to represent I now have 13 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sure do. Now I have plenty that I can take away 5. 1, 2, 3, 4, 5. Again, very kinesthetic. Let the students handle that. Away go the 5 units, and this is what you have left. And you clearly see that you've got 8 units left. Then you move to your longs. We only have 1 long left, as you can see, and we want to take away from that 6 longs. So we would want to go, we can say, oh, I see what's going to go on now. I need to break up a flat. I've got a problem. I don't have any flats. So if there is nothing to exchange, what you'll have to do is go to the next biggest unit, exchange the cubes for some flats so that you'll have a flat to exchange for the longs. So I will have to take my beautiful cube and trade it out for 10 flats. Let's count those out and make sure we have them. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you're in 3 dimensions, you can see this much more clearly, but indeed the cube gets replaced by 10 flats. Here's how that looks in my chart. The cube goes away that I create. I had no flats to begin with, but now I've got 10 of them. From that, I don't want to take away from the flats yet. I still have my longs, in trouble over here. Over here, what I would need to do, because I can't take away 6 longs from 1 long, is I'll need to take one of my flats, exchange that for 10 longs. Let's see if we can get 10 longs here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me get that flat I was going to take away and make sure I really see that. I see that it lines up perfectly. So when that flat goes away, it creates for me 10 longs. Let me scoot some fellows over here. Let's see, I think we still see those. Here are my 10 longs joining the one long I already have. So what happened to my flats? I had 10, but now I only have 9. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 flats are left because I took one away. I now have 11 longs. Finally, after all that work, I can take away 6 longs from the 11 longs. 1, 2, 3, 4, 5, 6. So let me show you here. I meant to do this. I want to show that when I bring this extra 10 longs over, I have 11 longs. Take away 6, and there's 5 left. So I had only 1 long, but I brought in 10 new longs. Then I can take away the 6 longs and leave me with 5. Finally, I have my flats moving from right to left, and I can take away 8 of those. So that's 8 flats I'm taking away, and I'm left with 1 flat, 5 longs, and 8 units, which is the number 158. In the meantime, let's see how well that matches up with what we think of as the standard algorithm for 1023, subtract 865, and let's see if we get the same thing. So in the ones place, we're trying to take away 5 ones from 3. We can't do that. So we take something from the tens place, meaning there's only 1 unit in the tens place anymore, creates 10 units. So we're borrowing from the tens place to the ones place using that traditional language. I've got 13 ones, which is like 13 units. Take away 5 gives me 8. In the tens place, I'm trying to take away 6 tens from 1 10. Can't do it. No hundreds to borrow from. So I take the thousands, use that to create 10 hundreds or 10 flats. Don't want to do anything here yet because I've got something not finished in my tens column. Borrow one of those hundreds, creating 10 more longs or 10 more tens. So I've got 11 in the tens place, 11 longs, take away 6 is 5. And then finally, this is pretty well marked up, but 9 hundreds minus 8 hundreds leaves me with 158. Now, in class, you would want to do a lot of examples and let the kids play with it for a long time until they get a strong comfort level. Sticking with this table for a good long while until they're very comfortable with that. Don't take off the training wheels for a while, but eventually you want to show them how you're essentially taking the training wheels off and you're illustrating the standard algorithm for subtraction. So I hope that is very helpful.